this lecture is going to talk about how we set up experiments and the things that we consider before we actually implement a research project. Step number one is to get a plan on paper. And so outlines make another appearance here for a lot of researchers. And there is going to be 10 major steps that we actually go through when we are planning a research project, whether it is part of a grant proposal that we don't even have money for, or whether it's a research project that we do have money for that hasn't been fully vetted. So this is kind of a 10-step process for how to start a research project. All right, so step number one, we've hammered this over and over and over again. I don't want to spend any additional time on it, but it is to review the literature. So we know why this is important for setting up a hypothesis and trying to figure out what information has already been done. It also is really going to help you take the broad approach. So look at different types of research that has taken place over or across several different disciplines. And that can really give you some perspective and some good information for how you can set up your study. Step number two is all about defining your objectives, which are going to be based on your hypotheses. And so the objectives, again, remember, they cannot be vague. They have to be very specific. They have to have an independent variable, a dependent variable, and an experimental unit. And the hypotheses are then going to take that objective and morph it into a statistical test. And we usually do that using an if-then statement. And so that hypothesis is really important for this step of gathering information and installing an experiment, because it becomes the testable question. And so just keep in mind that as we preach that objectives and hypotheses need to be very specific, they also need to be kept as simple as possible to decrease the amount of confusion that they can cause and actually decrease the amount of testing that they need to conduct. Because if you get a big expansive project that has 6, 7, or 8 different objectives, then that's going to result in between 8 and probably 24 different hypotheses. So a lot of stuff to test. Step number 3 is really starting to focus on what your population is. So this is where you need to decide what your population is and then how you're going to sample within that population. So this could be the species of animal or plant that you're actually concerned with. It could be a location like it is with the mineral study, so the grazing location. It could be a set of states. It could be on a national basis. Some really good examples are if we were studying papaya, we could study papaya in just Kauai, in the whole entire state of Hawaii, or look at papaya grown in sand or solution culture, where region really isn't even part of the question. And so some things that you need to consider at this point in time as you're fleshing things out is how is the population going to be sampled? And another question to ask is, will the results be specific to the sample studied, or can it be applied to the entire population? And either one of those scenarios is totally fine. You just need to be aware of what your data has the capability of predicting before you actually start the project. So step number 4 is all about figuring out if you can afford to test the hypotheses that you've constructed. So these are things that we've kind of mentioned before. So, is the experiment really set up to adequately test the hypotheses, given that all the resources are available? And so we've already been through a little bit of this. This is why we do statistical power calculations. And this is why we run simple statistics to make sure that we actually have enough power and enough bandwidth to answer a question or to detect a difference, given there is actually a difference to detect. And so the way to do this is to put together a working proposal. And I italicize the word working here with the thought process that this proposal can change and morph as you get more ideas and more information. And so this can be a place for you to get all of your costs and your materials and how many people it's going to take to carry out the project and what equipment you're going to need and any other additional needs in one document. And that document, again, is a working document, so it can be modified as needed. And so I personally really like this part of the planning process because I will start a document and get everything in there that I think I need, and then set on it a week or a month or a semester. And as things come to mind, I'll make a note in my phone as a reminder. It'll pop up, and I will go in and add those thoughts to that working document. So when I'm really ready to move forward with the research process, I've got a really good source of a lot of ideas in place. Step number 5 is all about selecting a research procedure. And this is not limited to just the treatment's design. It's also going to be related to the statistical process. And so this is where we're really headed next with the class. So when it comes to the treatment design, this is a really crucial step, and it really is a point of success of a research project or failure in achieving your objectives. And so this is the part that I encourage people to get lots of help with before they even start the experiment. Consult a statistician. Make sure you're going to have enough experimental units per treatment, and enough replications to actually detect a difference if there's one there to detect. Because if you overlook those type of things, those are really easy, usually, and fairly inexpensive to change at this point in the planning process. But if you go ahead and do the experiment and you don't have enough power to detect a difference, then you could have just wasted a bunch of time and money. The key to selecting a research procedure is to make sure that you gather data that is actually going to answer your question. I can't even tell you how many times I have reviewed grant proposals for, a granting agency or USDA or NSF or even just an internal grant here at this institution. And people don't really consider the traits that are needed to actually answer a question. And so that's why I encourage you to make sure that you get lots of eyes on this document before you start the project. So an example of this is in livestock research, we tend to use average daily gain as a good measure of efficiency. And in order to calculate average daily gain, you've got to know 3 pieces of information. You've got to know the beginning weight of the animal, the ending weight of the animal on the trial, and you've got to know the number of days in between. So you definitely better make sure that you're collecting that information if you want to use that information to create a new trait in your analysis process.